Okay, so welcome to Lecture 5 of this series. The goal for today is to talk about seventh chords, since primarily we've been talking about triads so far. We've talked about seventh chords a little bit and scales a good deal in Lecture 4, but I really want to get into thinking about seventh chords today, and honestly, I probably have about 2 hours worth of material to talk about for seventh chords, so it's very likely that we're going to split the content that I have planned on this subject into 2 lectures, so this week and next week. But the goal for talking about seventh chords is essentially to retrace the steps that we took with triads. That is, first we're going to talk about what happens with seventh chords within a key. That is, what can we say about diatonic seventh chords? And in particular, can we come up with some general algorithmic principle about upshifts and downshifts for seventh chords, like we did for triads within a major key? Then we're going to move on to talk about chromatic seventh chords. And by that, I mean considering all seventh chords working equally within the 12 notes of the equal tempered scale, and trying to see if we can come up with some overall understanding of all the possibilities for voice leadings between seventh chords, equivalent to the diagram we came up with in Lecture 3 called cube dance. So cube dance gave us a map of all possible progressions between major and minor triads. We're going to look for something similar for 4-note chords. So that's the overall plan, and as we do this, we're going to demonstrate the principles that we talk about by analyzing some music. And we're also going to talk about some really essential chord progressions, like the fundamental sense of progression and retrogression from classical chord grammar, and essentials of jazz harmony, like 2-5-1 progressions and tritone substitutions. So those are the kinds of music we're going to be talking about. So let's start by talking about diatonic seventh chords. And to do this, it's probably helpful to review our old rule for triad progressions within a key. You'll remember that we had a rule that allowed us to predict, when I'm moving between 2 chords within a key, whether I should connect those chords with an upshift or a downshift to find the smallest voice leading between them. So, for instance, if I'm thinking in the key of C major, and I want to compose something like 4 going to 2, the way that I predict what that should do is I should think about how the roots move between these 2 chords. A 4 chord is F major, and a 2 chord is going to be D minor. Now my rule for triads says that because this root motion is down by a third, I should upshift. Remember, if my roots move down by a third, a fifth, or a seventh, that calls for an upshift in triads. In particular, here, that upshift is going to take place with the C, which is going to move up by a step to D. And then the other 2 notes get to stay the same, since they're shared between the 2 chords. So that's a nice, simple 4-2 progression in C major. We want to look for something similar for seventh chords. So, for instance, if I wanted to do the same thing, but I wanted to make both of these guys seventh chords, so we would have 4-7 and 2-7. How is that going to change what should happen in the voice leading? Now you might predict that this is going to get considerably more complicated, because when we were dealing with triads, we didn't have too many different qualities of triads to deal with. We had major and minor, and there is technically one diminished triad within any major key. But when we start to deal with seventh chords, we have a lot more possibilities. We have major sevenths, minor sevenths, dominant sevenths, half diminished sevenths, or sometimes called minor 7 flat 5. And those are the 4 types that exist within a key, but there are also other types of seventh chords, like fully diminished seventh and maybe even minor triad major seventh. So there's a lot more possibilities for qualities of seventh chords. That might make this a lot more complicated to work with. But in fact, when we work within a diatonic key, the amazing thing is that the same rule applies. It's just as simple with one small tweak. And that small tweak is everything that was a downshift for triads becomes an upshift for seventh chords, and vice versa. So the directions of motions will change, but exactly the same rule applies. So what I mean by that is 4 going to 2 was an upshift for triads. Our rule predicts that it should be a downshift for seventh chords. Let's see if that makes sense. Well, what am I going to have to change here? To turn my 4 triad into a seventh chord, I'll need to stop doubling the root. So I need to get rid of my second copy of F and change it to E. So now I have a 7th in the 4/7 chord. And I'm going to need to target a 2/7 chord, which is going to be the notes D, F, and A. Just like when we worked with triads, let's imagine that there's some bass voice that's giving me the roots of the chords. And what I write on the staff, I'm going to try to just, I'm not going to worry about inversions or anything. I'm just going to take all of these notes to whatever is closest. So I'm saying that my rule predicts that this should work as small a voice leading as possible by doing a downshift. So let's see if that works. The closest thing that F can move down to is itself. The closest thing that C can move down to is itself, since C is the 7th of a 2/7 chord, D, F, A, C. Likewise, A gets to stay the same. And then the one thing that I'm missing is a D. This E is going to downshift to D, like so. There's no reason for that stem to move sideways. There we go. So you can see, I think you can really intuitively see that that's definitely going to be the smallest way to connect these two chords, because 3 of the voices didn't have to move at all. The only thing that I had to do was I had to take this E and move it down 1 step to D. It's the only thing that changes between the 2 chords. That's pretty similar to the fact that all I had to do to connect the triads was take C and move it up a step to D. So this was a 1-step upshift, and this, with 7th chords, is a 1-step downshift. So you can apply the same rule, just change the direction of everything that happens. And it applies not just to this one specific case, but to any possible progression. So, as I mentioned, one thing that I want to talk about today is the backbone of jazz harmony, which is a 2-5-1 progression. And I'll just write the Roman numerals with the implication that everything is going to be 7th chords. So really here I mean 2-7, 5-7, 1. So two 7 is going to be D, F, A, C. I'll write it out with a relatively 50 voicing to give myself a little space between the voices, but that's 2-7. And now let's try to apply the rule and predict what should happen to all of these voices. Now, 2 to 5, that's D going to G in C major. That's root motion down by a 5th. For triads, root motion down by a 5th means that we should upshift. But for 7th chords, we change the direction, so it should be a downshift. Root motion down by a 5th or a 3rd or a 7th should call for a downshift of 7th chords. So the notes that I need in my 5-7 chord are G, B, D, and F. Let's downshift to those. D gets to stay the same. A can't stay the same, so it should move down. The closest thing that it can move down to is G. F can stay the same, and C cannot stay the same. It'll downshift to B. The overall amount of motion here, C moved by 1, F moved by 0, A moved by 2, and D moved by 0. So the overall amount of motion in this progression from 2/7 to 5/7 is 3 semitones. I think by now you probably should have a sense that 3 semitones is not a lot of motion, especially for a chord that has 4 notes in it. All right, so now to go from 5/7 to 1/7, we should think through the same thought process. The root motion is going to be G to C. That's another root motion down by a fifth, so that should call for another downshift of 7th chords. My 1/7 chord requires the notes C, E, G, and B. So let's downshift to them. D is going to downshift to C. G downshifts to itself. F downshifts to E. And B gets to stay the same. This is, of course, one of the big differences between jazz harmony and classical harmony, because in classical music we would expect the B to resolve back up to C, but in jazz it often works pretty well to resolve to a 1/7 chord, a 1 major 7 chord. Again, not a lot of motion going on here. Down by 2, down by 0, down by 1, down by 0, for a total of 3 semitones of motion. So that's the basic rule. And just to state it one more time, it's the same rule as for triads, but with the directions reversed. So the rule is, look at the root motion. If the root motion is down by 3rd, 5th, or 7th, the smallest voice leading will be a downshift. If the root motion is up by a 3rd, 5th, or 7th, the smallest voice leading will be an upshift. And that works for any progression of 7th chords that stays within a single key. Anytime you have 2 7th chords that could fit into a key together, their smallest voice leading will be governed by this rule. So let me give you a progression to try to realize and see if you can apply this rule. Let's stay in the key of C major. And the progression I want you to do is 1/7, going to 6/7, going into 4/7, and 5/7, and then back to 1/7. And again, all of these sevenths, don't make them major minor sevenths, just make them diatonic sevenths within the key of C major. Don't worry about inversions, just stick with whatever voice leading you end up with following the rule. And your initial 1/7 chord, start with this voice leading, again just to space the notes out nicely. If we're all following the rule in the same way, our top note, this E, should end up in the same place if we're all doing the same thing. So my question for you to share in the chat when you're done is, what note does this E end up on? So that's where I end up, and as you can see, I do end up finding this E, the top note, does move down overall to C by the end of the progression. If we go through and think step by step about what happened, this first root motion was down by a 1/3, so it should be a downshift. The next root motion 6 to 4 is down by a third, so that should be a downshift. The next root motion is down by a seventh, F to G, or up by a step. That too should be a downshift. And then G to C is down by a fifth, so that should be a downshift. So this is a progression that turns out to require entirely downshifts. All of the voices just move down over the course of the progression, so that from the first one to the last one, this root ends up becoming the seventh, the third ends up becoming the root, and so on. So this is one of those progressions that seems very directed from beginning to end. Of course, this particular voice leading I think is going to sound kind of gross because we end up putting the seventh of the one chord in the lowest position, in the bass, which I don't know that we're going to be super happy with, but we could tweak the one chord that we started with to get a better result in the end. Let's hear what this sounds like. So here's my initial one chord, and here's the progression. Yeah, it doesn't sound super great to have that seventh down in the bass. But if I had a bass player or somebody playing the roots of these chords beneath my progression, it might sound a little bit better. Let me try to condense this so that I can play the whole progression in my right hand. It'll sound like this. Yeah, I like that better. With a little bit of bass support, it works pretty good. So that's the basic algorithm for seventh chords within a key. I think the next thing that we should talk about, if we're just following the track of the things we considered with triads, is we should talk about the possibility of ties. So this is our general rule, but for triads, we had an exception or a complication. What about ties? And by that I mean, when we dealt with triads, we saw that sometimes, for instance, when you had a progression that went 4, 5, the rule for triads told us that this progression should be an upshift. And indeed, upshifting for going to 5 does require 6 half steps of motion. But this is a special case, because you could also do this as a downshift, and that would also only cost 6 semitones of motion. So there were certain special cases for triads where you could upshift or downshift, and the overall amount of motion would be the same. Specifically for triads, that happened when the root motion was by major second, and the qualities of the chords matched. So the question is there anything like this for seventh chords? And the answer is yes. You should pause and ask yourself what you guess it's going to be. Can you predict where the ties will occur for seventh chords? And honestly, I don't know that I could. It's a little bit surprising to me where ties occur. They do happen. Specifically, they happen in situations like this. So for example, if I have 1 7, like C major 7, going to 2 7, D minor 7. Or another place where a tie happens is if I have 3 7 go to 4 7. So that is something like E minor 7 going to F major 7. Both of these, the rule would predict that it should be a downshift, but it turns out that you could upshift these progressions and move the same amount of distance. So specifically, you end up with ties. You could go either up or down when the root motion is by step. And here I mean just diatonic step. It doesn't matter whether it's a whole step or a half step. and the quality changes. Specifically when it switches between major 7 and minor 7. So here, for example, root motion from 1 to 2, that's by a step, and we went from a major 7th chord to a minor 7th chord. Notice, importantly, that means that there will not be a tie if I have a progression from 4-7, which is a major 7th chord, to 5-7, which is a dominant 7th chord. Since this guy is neither a major nor a minor 7th chord, that one, this progression, 4-5, won't be a tie. It'll just follow the regular rule. So because that's a step up, this should be a downshift. So it's specifically just these two qualities of 7th chords where we're going to find ties, at least while we're working within a single key. I think it's good to see what that looks like in action. So let's do it with 3-7 going to 4-7. I don't know of a lot of music that actually uses that as a progression, but it's interesting to explore. So sticking with the key of C major, that's going to be E minor 7 and F major 7. And let's first of all do it the way that the rule predicts. So a step up should be a downshift. So downshifting from 3-7 to 4-7, what I need in the 4-7 chord is F, A, C, and E. E could stay the same. B will have to downshift to A. G will downshift to F. And D will downshift to C. By the way, again, I just want to pause and appreciate how remarkable it is that this works. Like, I'm following a simple rule, and not only does the simple rule give me the smallest connection, but it also happens to, for example, give me complete 7th chords at every stage. So the overall amount of motion in this downshift is 2, 2, 2, and 0. Sorry, my mental math gets real bad sometimes. 2 added to itself 3 times is a total amount of motion of 6 overall. So if I take this same progression, 3 going to 4, and I do this as an upshift, somehow that should end up being 6 semitones also. So to upshift this, E would end up moving up to F, B would end up moving up to C, G would end up moving up to A, and D is going to end up going up to E. Here, E moves up by 1, B moves up by 1, G moves up by 2, and D moves up by 2. So more voices move, but some of them move by smaller amounts. These two only move up by a half step. 2 plus 2 plus 1 plus 1 also equals 6. So these are in fact tied. This was down by 6, and this is up by 6. Oh, you know what? You're absolutely right. Technically, E should stay the same. Technically, if we're strictly wanting to do the upshift rule, I guess this doesn't work for me. If we're following the rule from lecture 4, right, where you just sort of cycle everything according to where the first note goes. So if this first note here, the D, the 7th, becomes the 7th of the next chord, then the 3rd should become the 3rd, the 5th becomes the 5th, and then the root becomes the root. So here, I guess I was unconsciously shifting over to thinking about things in terms of the rule from lecture 4, rather than the original definition of upshifts and downshifts from lecture 1. So you're absolutely right to call me out on this. I was not being careful enough in my thinking. This is technically what the upshift would be, and it doesn't give me a complete chord. Notice, though, that the place where this fails, where an upshift fails, is the thing that our rule for working within the key This is the thing that the rule doesn't predict. The rule for diatonic progressions with upshifts and downshifts says that it should be a downshift. And here, I'm pretty certain that actually the downshift does work. I think the next thing that we should ask is, why does this work at all? Why do seventh chords within a key follow the same rule as triads within a key? And this is probably the most abstract theory that we're going to do. I think it helps to visualize it. So again, the question is, why does the same rule predict both triads and seventh chords? And to answer that question, I want to visualize it on the following kind of diagram. What I've written out here is basically just a diatonic scale. I picked C major arbitrarily, but you could just as well represent this with scale degrees like 1, 2, 3, 4, 5, 6, and 7. And I've taken the scale and I've written it out on a circle with the idea that if you go around any scale, you just go up a C major scale, eventually you get back to C. So I'm thinking about clockwise motion around the circle as being motion up, right? C to D is like a step up. Clockwise motion ascends, but eventually it'll ascend back to the note that you started on, technically an octave higher, but we're going to collapse octaves into unisons. So you can sort of continue to climb the scale until you get back to where you started. And I want to use this way of visualizing the diatonic scale to think about what's going on in the kinds of chord progressions that we were composing. So for instance, because we were working with a 2-5-1 progression before, let's try to visualize what a 2 chord looks like and then what a 5 chord looks like in a picture like this. And let's start by thinking just about triads. So a 2 chord in C major is D, F, and A. And then a 5 chord in C major is G, B, and D. Now, if I'm thinking about the voice leading between these 2 chords, what happens? A goes up to B, and F goes up to G. Right, so F upshifted to G, A upshifted to B, and then the same thing here, A upshifted to B, F upshifted to G. And that's what we would predict using the rule from lecture 1. 2 to 5, root motion down by fifth, should be an upshift. So really all I'm doing is I'm trying to use this thing to visualize stuff that we've already seen. I'll take this same progression, and now I want to draw your attention to the other notes, the notes that are left behind. So in my 2 chord, I had D, F, and A. What are the other notes that are in the scale? E, G, B, and C. And then what are the other notes that are left behind after I spell a 5 chord? Well, there's an A, a C, an E, and an F. The technical term for the relationship between blue and red here is complement. So we talk about the complement of the 5 chord as being A, C, E, and F. The complement of the 2 chord is G, B, C, and E. And the kind of cool thing here is that if I delete the blue notes, if I just ignore them and I think about what notes are spelled by its complement, well, F, A, C, E actually spells the 7th chord. It's a 4-7 chord. What's the complement of a 2 chord? C, E, G, B. That's a 1-7 chord. So within a diatonic scale, triads and seventh chords are complementary. If you take a triad out of the scale, what's left over is a seventh chord, and vice versa. Now, the really cool thing here is that not only are chords complementary with each other, but voice leadings are complementary with each other. In other words, what I mean by that is when A moves up to B, when I go from 2 to 5, or when F moves up to G, what that does is A moving to B creates a hole at A and forces B out of the picture. So in other words, when I'm thinking about the complementary chord progression, B here is forced to move into the hole at A. And G, likewise, in the complement, is forced to move to fill the hole at F. So a 2-5 triad progression is complementary to a 1-4 seventh chord progression. And the voice leadings between those chords have to be opposite to each other. So if 2 to 5 is an upshift, 1 to 4 is going to be a downshift. Moreover, notice that although they move in opposite directions, the type of root motion is the same. Here, the root was D moving to G. That's a root motion up by a fourth. Likewise here, the root is C moving to F, root motion up by a fourth. And that's going to be true for any pair of complementary chord progressions. The root motion will be the same size and direction, but the voice leading will be opposite. And that's pretty cool, right? That explains entirely why the rule that applies to triads applies exactly to seventh chords as well, but pushing in the opposite direction. We could imagine doing similar sorts of things with other kinds of root motions. So for instance, let's try this with root motions by third instead of by fourth. So for instance, let's imagine doing a root motion from 1 to 6 as triads. So a 1 chord is, of course, C, E, and G. That'll go to A, C, and E. And for triads, root motion by third is the smallest possible kind of connection between two triads, since C and E can both stay the same. There's only one step that has to happen. G has to step up to A. What that means is, if I think about the complements here, let's see, my complement right here is B, D, F, and A. I suppose that's a 7 half diminished 7 chord. And then my complement over here is going to be G, B, D, and F. That's a 5-7 chord. And again, the complementary voice leading is A is going to have to go down to G. So again, root motion for seventh chords by third, so root motion down or up a third, is going to be the smallest possible connection between diatonic seventh chords, just like it was for triads. And so you can go through and you'll see that seventh chords and triads, their smallest connections are root motions by third, root motions by fourth are sort of medium, and then root motions by step are going to be the largest amount of motion between triads or between seventh chords. So I think this is just really cool, that a voice leading within some subset of a scale forces a complementary voice leading on the complement within the scale. This works out really nicely for triads and seventh chords within the diatonic key. But if you want to explore this more, You can do a really similar thing within the chromatic scale if you think about major scales and pentatonic scales. Since if you think about the white and black keys of a keyboard, you know that the white keys and the black keys are complementary to each other, right? They don't overlap, but together they make up the whole chromatic scale. And as we talked about in Lecture 4, you can think about the circle of fifths modulating with the major scale as upshifting or downshifting between various major scales. That means that you should be able to predict what the pentatonic circle of fifths looks like. Right? If you want to think about it, voice leadings between diatonic scales should force some kind of voice leadings between pentatonic scales. Equal but opposite motions there. So if you want to explore this idea farther, that's a thing I think you might have some fun considering, is what does the pentatonic circle of fifths look like? And then if you want to go really out there, you could think about what's the complement of like a melodic minor scale. There's some 5-note scale that's complement to melodic minor. What does its circle of fifths look like? You can find some pretty fun stuff there. One last point that I want to make on this subject is I think that this principle right here also explains a really fundamental aspect of classical music's chord grammar. You'll remember that back in Lecture 1, I said that classical music really seems to prefer upshifts for triads. That is, for example, classical music really is quite happy with the progression like 1, 6, 2, 5, 1, since for triads, every one of those connections is going to be an upshift. 1 to 6 is an upshift, 6 to 2, root motion down by fifth is an upshift, 2 to 5, upshift, 5 to 1, upshift. And I said that's a simple way to remember nearly all of the chord progressions that classical music prefers when it's working with triads. We now know that the same thing is going to be true in the opposite direction for seventh chords. And I actually think that the seventh chord preference came first, historically. That this fundamental principle for classical chord progressions actually comes from the fact that this progression, if you did it with seventh chords, would be all downshifts. So that is, if I turn it to 1, 7, 6, 7, and then 2, 5, 1, like in jazz, that will be entirely downshifts. The reason for that is classical music, classical harmony, has a very, very strong rule, which is that the seventh of any seventh chord really strongly desires to resolve down by step. So if I write a chord like 5, 7, for instance, or actually, why don't we start with 1, 7? 1, 7 would have the notes C, E, G, and B. Classical music says this B right here, it's the seventh of the chord. It has a strong desire to resolve down by step to A. That rule actually predates tonal harmony altogether. It goes back to the Renaissance. It sort of predates a lot of the stuff that we learn about classical harmony. And it's one of the strongest and longest lasting rules in tonal harmony. And in fact, I think it continues to survive in some form even into popular music from the 20th century. So it seems to be some really powerful principle. Somehow, if you add a dissonant note to a chord, it feels nicer for that note to go down a lot of the time. That's just like a basic axiom for classical harmony. And if you start from that axiom, that really strongly constrains what chords I could go to after my 1-7 chord. So if I start from a 1-7 chord, where can I go? I can only go to chords that include A, and if I care about the voice leadings, I can only downshift to those chords. So for instance, 6-7 is one possibility. Other possibilities would be like 4-7 or 2-7. And that basically tells you exactly the chords that classical music would prefer to move to, or the kinds of root motions that classical music would prefer to use. And then, if we think of chords as being basically the same if they have the same root. That is, a 1 chord is basically the same kind of thing as a 1-7 chord. A 2 chord is basically the same kind of thing as a 2-7 chord. All of those chord progressions that are forced on us for 7th chords, if we continue to use them when we translate them into triads, that'll give us upshifts for the triads and downshifts for the 7th chords, and that's basically where 90% of the chord grammar for classical music comes from. And I think if you look historically at what kinds of chord progressions tend to get used, historically you can watch it emerge out of this rule for 7ths resolving down. I think that's pretty cool. By the way, if we go back to this root motion by third right here, notice that there's a really convenient fact, which is that root motion down by third, like from 7 to 5, the one note that has to move, A, which moved down to G, is in fact the 7th of the chord. That's real dang convenient. That the smallest possible voice leading for these root motions, root motion down by third, is exactly the voice leading that lets us resolve the 7th down by step like classical harmony wants to let us do. So there is really something sort of fundamentally powerful about root motion down by third for classical music. So I think this is probably a good place to break for today. We're about halfway through the material that I think we should talk about for 7th chords, which means we do really have about another hour's worth of material to do. Let's save that material for next week. So just to review, the lesson for today is when you're working within a key and you want to use 7th chords, the same rule applies as for triads, but the direction of the voice leading will be opposite. All right, I think, yeah, that's it for me for today, but I'm happy to stick around and answer any questions or talk through examples if there's anything else you'd like to discuss. Okay, yeah, so I gave a problem set following up from, I forget, that was lecture 3, where we had that diagram called cube dance, and I said, this diagram for 3-note chords only includes major triads, minor triads, and augmented triads. But those aren't the only kinds of chords that we care about. We also care about diminished triads and maybe stuff like sus4 chords. And certainly we care about diminished triads because those exist within diatonic keys, so it seems like we ought to include those somewhere. Could I give a hint for how to think about that? Sure. I would say let's start from what we know about how this diagram works, which is that 2 points on the diagram, like C major and C minor, are next to each other and connected. If you can get from one to the other just by moving one voice by 1/2 step. And let me think about how I could get to one of these other qualities of chords by just tweaking something by a 1/2 step. So for instance, let's do diminished triads, and let's think about B diminished. So that would be B, D, and F. Is there a way that I can get from B diminished to a major, minor, or augmented chord just by moving something by a 1/2 step? Can you see how we could do that? You might just start taking these notes and like tweaking them around, right? So for example, D, if I turn that to D flat, does that give me a good quality chord? B to B flat, good. So for example, B diminished is just 1/2 step away from B flat major. And that tells me, or it should tell me, where B diminished would want to live on this diagram. So it should be close to B flat major, and we should be able to predict what direction it goes as well. Since we know that clockwise motion is downshifts and counterclockwise motion is upshifts. So B flat major to B diminished, I would get rid of the flat, which means moving this note up. So to go from B flat major to B diminished, I have to upshift by 1, which means I should move in this direction by 1. That tells me that if I want to preserve the logic of the diagram, I really probably should put B diminished. Maybe I'll write B dim. That probably should live right here on the diagram. And there should be a line connecting B flat major to B diminished as a point right here. B diminished has to be, that'll look better if I make it a circle. B diminished has to be its own shape, or its own dot on the diagram, since it's not the same chord as D augmented, but it should live sort of at the same point on the circle. It should be at like 6 o'clock if we visualize this as a clock. Now I think we should also ask ourselves, is that the only chord that B diminished is connected to? First of all, since B diminished and D augmented live sort of both at 6 o'clock, I should ask, could they connect to each other? And the answer there is no, since D augmented is D, F sharp, and B flat. Right? So B diminished and D augmented, the B moves to B flat, but the F moves to F sharp. So they're not connected because there's 2 steps of motion that has to connect those two. But we might ask, does B diminished connect to any of the other things here? Does it connect to F sharp? Well, turns out no. Does it connect to D? Turns out no. How about over here? Can you take B diminished and turn that into any minor triad with just a 1/2 step tweak? Good, yeah. So I can take F, and if I raise that to F sharp, that gives me B minor. So B diminished connects to B minor like that. And it turns out I could check these other 2 possibilities, E flat and G. It turns out that it won't connect to either of those with just 1/2 step of motion. So that's the basic idea. You could apply this, you can use this to figure out where all of the other diminished triads should go. You can use a really similar logic to figure out where all the sus4 chords ought to go. That's a great question. I'm glad you asked it, because I think this kind of thought process will be really helpful for us once we try to imagine what this diagram for 7th chords will look like, or what the equivalent diagram for 7th chords will look like. You'll want to use a really similar sort of thought process to understand that. Good, so great question. Do you or anybody else have any others? So if one pictures the notes as if it were part of a guitar tuned in major thirds, a lot of these topics are easier to understand visually. So what you're describing here, is essentially is a kind of diagram that music theorists call a Tonnetz. So for example, here I've written out some major thirds, and I guess we're imagining these as sort of like the strings of a guitar. So for example, that's a string, that's a string, that's a string, and then this 4th string gets back to C. And then sort of the frets, you would say, well, there's C sharp, F, A, back to C sharp. So all the frets of the guitar would raise things by 1 semitone. And then above that, you would have D, F sharp, B flat, D, and then E flat, G, B, E flat. Am I representing the picture that you have in mind accurately? So we're imagining laying out the 12 notes, something like this, with the idea that horizontal connections are always motions by major third, and vertical connections are always half steps. So basically you have a two-dimensional lattice where the two dimensions represent different sizes of motion. Yeah, so I think this has to do with like what you find intuitive and whether you play guitar or not. I'm a cellist by trade, so this spatially corresponds more closely to how I conceptualize like strings. But yeah, it would be the same thing if I rotated this 90 degrees. This kind of diagram is something that's called a Tonnetz, which is the German word for like a network of tones. And it's a kind of diagram that goes back to 18th century mathematician named Leonhard Euler, who explored music theory. He was a brilliant mathematician and came up with some ideas about music theory. He used diagrams like this to visualize some properties. By the way, there are also this kind of layout is also sometimes called an isomorphic keyboard. People have designed sort of updates for pianos that use this sort of layout, which makes transposing between keys a little bit more systematic than the normal like white keys plus black keys of a piano. But this is certainly this can be a good way to visualize certain possibilities. The version of this that music theorists prefer to use chooses different axes. So the thing that I drew, the two axes going up and going to the right, the way that I drew this is a major third going to the right and a minor second going up. But you could pick different intervals. So like you said, we could rotate this 90 degrees so that you had major thirds at the top and you had minor seconds over here. Could think of that as a rotation or a reflection. But actually what music theorists prefer to do is they like to think about it with perfect fifths on one axis and major or minor thirds on the other axis. And if you do it that way, that makes it really convenient to visualize stuff like triads. So you could imagine, for example, putting a G and then a D and then an A, and then putting E right there, and then B would go right here. I'm feeling a little brain dead today. That's F sharp, that's C sharp, and so on. And you can see how if you lay it out like this, which is generally what academic theorists like to do, you can see why stuff like triads become really easy to visualize with this layout. Because C, E, G, a major triad is sort of this kind of triangle. Whereas if I want to think about a minor triad, for example, B minor is B, D, and F sharp. A minor triad then is sort of the other half of these squares. So you can visualize major and minor triads pretty conveniently on a Tonnetz that's laid out with these axes. And it does make it easier to visualize certain questions like this. Personally, I've never found this as intuitive as a lot of people seem to. So if you find visualizing stuff on the Tonnetz really helpful, yeah, totally. A lot of people really like to use this sort of thing. It's never really clicked with me, which is why I haven't been using it in my lectures. But it's totally a useful sort of resource. Here's my bibliography for today's lecture and next week's lecture. One of the things that I'm sharing with you is this book, Audacious Euphony by Richard Cohn, which is a book I've cited before. This book does use the Tonnetz to visualize these sorts of questions. Richard Cohn is really sort of the person, or one of the main people, who really helped to bring the Tonnetz back into contemporary music theory. And so Audacious Euphony, if you find this style of visualization helpful, I think you would find that book really amenable to visualizing these sorts of questions. Thanks everybody for tuning in today. Come back next week for the second part of our discussion of seventh chords.